vision basics. Now let's talk about what are the other deep learning, for self-driving. So start from vision. We have object detection. We get the bounding box, as you just see, and the speed and the heading of the vehicle. And then we predict the trajectory of other vehicle. Or hopefully they're not hitting you. They're not coming against you. They're not doing like, they're not like drunk driving and they're just getting the wrong lane, right? You need to predict that. After that, after you predict everything, hopefully accurately, then you can do planning and you do mapping. Let's see what's the prediction problem looks like. So this is like, don't spend time to read those texts for now. I'll just tell you roughly what's going on. The blue car is a self-driving car. The red car is another vehicle. So you need to predict the route of the red vehicle because it's on the very right side, right? And very likely it's either go straight or right turn. It seems safe for you because your planning is turn right. You're going opposite. However, the prediction cannot just output one trajectory. Say, hey, I don't need to worry about this. You never know. They may change idea. They may change mind. They may realize they go in the wrong direction. They may turn left, right? And they may come across you if they go fast. So you need also predict all the possible trajectory with probability. If they turn left, what are the trajectory? Will they hit you? At the same time, came to the same spot. You need to predict all this contingency situation. So that's the prediction problem you need to solve. So what are the different kind of prediction problem in general, right? So we all know, like the very popular prediction problem is predict web page clicks. Will you click this advertise? How much money I will make? Will you watch this video? How long you will watch? Will you subscribe this channel? Will you buy this product? And also, will you connect to this person, right? And view his post, his or her post. And also, like in the real world, you predict the stock market. You predict the weather. You predict whether medicine is useful. You predict the DNA from saliva. And certainly in self-driving car, we predict motion. Actually, surprisingly, all this prediction nowadays use pretty much the same technology. With that, I will share one career advice. Basically, since the nature of the world problem is so inherently related, once you build deep insight on the problem, on the space, you can apply the skill in many, many areas. So don't be too anxious for where you start. Worry more about how much insight you get. The framework of the prediction problem, essentially, your goal is to get the sequence of events going to happen next at that point, right? The knowledge you have is the surrounding context and the observation from the past and the interaction, the distance interaction between those entities, right? The solution, in the deep learning world, the solution is you first derive features from observation. You derive very effective, cost-effective, precise, concise features. Then you use these features, make calculations, like convoluted neural network and other neural network. You make calculations that many layers. Then you roll out sequence of prediction events, right? So this is a very common structure of a neural network cell, okay? So you have memory from the past. You have your immediate input, and you need to smartly decide what to forget from the past and what to take from the current input. And how do you update your state of the current moment? You keep rolling out the states. You always have a current state. How do you update the state? And how do you compute the output for next prediction and next state, right? Basically, all this just matrix multiplication calculation, right? To rolling out the understanding of the states and digest the history and predict the future, right? Some memory has very long-lasting effect. Some only have short effect, right? And yeah, so it's very similar to human to predict what happened next. Is these two kind of problem, like translation and missile defense, is the same. You have a sequence of words from one sequence, one language to the other language, or one sequence from the past to the other sequence of short-term future, right? So you encode the past, you decode for the future, right? And the same thing for the missile defense. You observe where the missile comes, right? What point it has it land in the past, and what's vessel, the wind blow direction, and so on. And you predict how this missile will land, right? Then basically it's a sequence to sequence. Same thing for planning, right? Planning, essentially, you plan multiple trajectory based on all the prediction, right? You roll out the sequence of actions you should take, and you probably roll out several possible sequences of your self-driving car, the blue one, to the future route. That's the motion planning, essentially. The state of the planning is we still rely a lot based on the expert system with thousands of rules and decision trees and with parameters to decide, in what situation, in the state, in the section, and how do you follow call, how do you take over, we put rules, right? But people are moving toward not that quick toward a data-driven based system, a learn planning system. People use imitation learning, follow the expert driver, and people are researching reinforcement learning, right? Basically when we train a dog, it's a reinforcement learning. The dog is the agent. They see us as the environment. They take action. They see if one action got a reward or not, or penalty. Then they use that observation to adjust their behavior, right? Same idea for reinforcement learning in other world. So some fun thing, right? Yeah, I think I'm on time. A few more slides. Let's ask the topic for AI. When a self-driving car on the road, right? There's a baby, there's an old baby. I mean, if you're running so fast, you have to, hurt someone. Which one to hurt? Certainly, we don't want to hurt anybody, right? And some fun time, the self-driving is in the mission these days. People are using it to deliver stuff. But look, construction worker forgot to put tape, and the cement is still wet. It's hard to tell. The self-driving car just trapped there. But given all this difficulty, challenge, people are operating self-driving car already to shipping goods widely. So this has become very reality. So I don't, basically this because you don't have video, right? This is a fun data. Essentially, one day, I think you'll miss your truck. You'll miss your truck. I think all the car will drive 150 miles on the road. At that time, it got to be very brave to drive together with the self-driving car. You will miss your truck. You'll find this video on YouTube. Sorry about that. Right. My self-driving truck left me, but I still have my dog and tractors. All right. That's all the content I have. So I guess now I can take questions.
So any student want to ask questions? You can raise your hand. We can call your name.